Hello all, welcome back to another video. My name is Sriram Rakshit CV, studying in Sri Venkateswara College of Engineering, Bangalore. My USN is 1V22IS051 and the subject we're gonna discuss about is data structures and applications. The topic is optimal binary search trees. So let's go. Optimal binary search trees in data structure. So what is optimal binary search trees? Introduction to optimal binary search trees. Optimal binary search trees are a data structure that minimizes the average cost of searching within a tree. The basically type of data structures which reduces the cost of searching within a tree, minimizes the average cost of searching within a tree. They're commonly used in scenarios where frequent searches are performed on a set of keys. The used where keys matters. The goal of an optimal binary search tree is to reduce the total cost of searching by minimizing the average search time. This basically reduces the time. Optimal binary search tree saves the time. Basic concepts of binary search trees. Binary search trees are a type of data structures where each node has at most two children. So, what is binary search trees? Binary search trees are a type of data structure where each node has at most two children. In a binary search tree, the left child of a node contains keys less than the node's keys, and the right child contains keys greater than the node's key. Searching in a binary tree. Searching in a binary search tree has an average time complexity of O log n, making it efficient for searching operations. And what is the importance of optimal binary search trees? Optimal binary search trees reduces the average search time by organizing the keys in a way that minimizes the total search cost. By placing frequently accessed keys closer to the roots, optimal binary search trees can significantly improve search performance. This places keys closer to the roots such that the searching becomes easy. Thus, especially useful in applications where search operations are a critical part of the system's functionality. Construction of optimal binary search trees. Now, this is important. The construction of an optimal binary search tree involves determining the arrangement of keys that minimizes the total search cost. The construction of an optimal binary search tree involves determining the arrangement of keys that minimizes the total search cost. This process is typically done using dynamic programming techniques to find the optimal arrangement efficiently. These are done using dynamic programming techniques. The construction of optimal binary search trees is a non trivial problem that requires careful consideration of key frequencies and probabilities. And dynamic programming approach. Dynamic programming approach is a common technique used to construct optimal binary search trees. This approach is used to construct optimal binary search tree. The dynamic programming approach involves breaking down the problem into subproblems and solving them. This approach involves breaking down the problem, splitting the problem, and making them into subproblems and solving them. By storing the results of subproblems in a table, dynamic programming can efficiently find the optimal arrangement of keys in a binary search tree. This approach is to find keys in a binary search tree. And cost function in optimal binary search trees. The cost function of searching in a binary search tree is typically defined as the sum of the search time for each key weighted by its probability of being accessed. The cost function in optimal binary search trees aims to minimize the costing, minimize this total search cost. By considering key frequencies and probabilities, the cost function can determine the optimal arrangement of keys in a tree. See this cost function in optimal binary search trees. is typically defined as the sum of the search time for each key. Okay, by adding all them, we get the probability of being accessed. The function in optimal binary search trees aims to minimize this total search cost. It helps to reduce the total search cost. Key probabilities in optimal binary search trees. Key probabilities plays a crucial role in the construction of optimal binary search trees. This plays a crucial role in optimal binary search trees. The probability of accessing a key affects its placement in the tree, with higher probability keys typically placed closer to the root. As we discussed, the keys which needed most are placed closer to the roots. The probability of accessing a key affects in optimal binary search trees. By considering key probabilities, optimal binary search trees can minimize the average search time across all the keys. This key probabilities helps minimize the average search time. An example of constructing an optimal binary search tree. Let's consider an example where we have keys 1, 2, 3, 4 with probability zero point 0.2, zero point 0.4, zero point 3, zero point 1 respectively. Using dynamic programming approach, we can construct an optimal binary search tree that minimizes the total search cost. By arranging the keys based on their probabilities, we can achieve an optimal binary search tree structure. And what are the advantages of optimal binary search trees? Optimal binary search trees provides a more efficient search operations compared to standard binary search trees. It is more efficient than the other standard binary search trees. They're particularly useful in scenarios where such program is critical, such as database and information retrieval systems. They play a crucial role in this databases and information retrieval systems. By minimizing the average search time, optimal binary search trees improve the overall efficiency of the system. As we discussed, it helps with the efficiency of the system. It minimizes the average search time. And what are the disadvantages of optimal binary search trees or limitations of optimal binary search trees? Constructing optimal binary search trees can be computationally expensive, especially for large set of keys. It becomes complex when we are doing it for huge number of keys. The need to consider key probabilities and frequencies adds complexity to the construction process. And again, key probabilities and frequencies adds complexity to building this structure. Optimal binary search trees may not always be practical for all applications due to their computational overhead. This all makes this optimal binary search trees to be not always be practical for all applications, to be suits for all optimal to suits all such activities. Applications of optimal binary search trees, and where do we use this search trees? Optimal binary search trees are commonly used in database indexing to improve search performance. They are commonly used in database indexing. This is the basic need of database indexing is optimal binary search trees. Information retrieval systems benefits from optimal binary search tree for efficient keyword searches. And again, information retrieval system also gets advantage from this optimal binary search trees. Compiler design and symbol table implementations often utilize optimal binary search trees for fast lookups. Since optimal binary search trees are more efficient and easy search trees, they are also useful in compiler design and symbol table implementations. And conclusion: optimal that minimizes the average search time by organizing keys efficiently. One of the major advantage, and from the beginning I'm saying that is optimal binary search trees are a powerful data structures that minimizes the average search time by organizing keys efficiently, clo- which are very important keys that are placed close to the roots. And by considering key probabilities and frequencies, optimal binary search trees can significantly improve search performance. This helps with search performance by considering key probabilities and frequencies. Okay, this helps to improve search performance. Understanding the construction and benefits of optimal binary search trees is essential for designing efficient search algorithms. And for developers, it is uh, it is good to understand this construction and benefits of optimal binary search trees of to design something, or to designing efficient search algorithms. And yeah, these are all we learned in this video: introduction and basic concepts of binary search trees, and its importance, and construction of optimal binary search trees, and what is dynamic approach, cost function in optimal binary search trees, and key probabilities in optimal binary search trees, and it's one of its example, and advantages of course, and disadvantages, and applications where we use like in data indexing, and and information retrieval systems, and compiler designing, and symbol table implementations. Yeah, and that is all for this video. Hope you understand optimal binary search trees. If you understand and like this video, please share with your friends and also subscribe.